Hi, everyone. I wanted to hop on and show you a really quick application of this week's content in psychometric theory to the SAT as an example. So, part of my work in my full time job is to educate teachers and parents about assessments. And I usually give a presentation about the SAT and the ACT to our parent faculty associations in both of our high schools. And one of the questions I used to get prior to this presentation and teaching this class is it true that the June SAT is easier than the May one for XYZ reason? Or is it better to take it in October than May? Again, for whatever reason or rumor they heard. And the answer to that is no. And the reason for it has to do with transforming scores and equating, which is this week's topic in psychometric theory. So, what I did here was I took a screenshot of the math scale, or a portion of it anyway, from two different SATs. And what you'll notice is that, and first of all, let me give some background. So on a math SAT, there's 58 questions altogether. There's 20 on a non-calculated part and 38 on a calculated part. So a student can earn up to 58 questions correct and then lose points from there. The SAT has no guessing penalty. So when a student takes an SAT, they're basically their score comes from how many questions do they get correct out of a possible 58. And for each assessment that's given, there's a scale provided that accompanies that test, and the scale's not the same for every test. The folks at the SAT, the College Board, people who know psychometric theory, they want to make sure that there's consistency across different test administrations, that a student sitting in one month should get a similar experience to a student sitting in another month. But of course, that's not perfect, right? Like the mix of questions can vary, and then as a result, difficulties can vary. So they use a process called equating to make sure that a score for a test taken on one date is equivalent to a score from a test on a different date. And what that means is that if I get one wrong in March on a harder test, my penalty may not be as steep as if I get one wrong in May when the test is a little bit easier based on the statistics that they're pulling in. So just to show you how extreme this could be, I took two different scales that I obtained from released exams. The one on the left is a harder test. And by that, I mean a student can get one wrong on that math SAT and still get a perfect score of 800. In fact, on this particular test, it was so hard, a student could get three wrong and still get a 790. That just meant, for whatever reason, that month when kids sat and took it, the questions were just very difficult. Maybe it was intentional, maybe it wasn't, and that comes with item analysis, which we'll talk about later in the course. Could the question quality have been improved? Were there distractors that discriminated against students? What was, we don't know what it could be, but that comes from a more nuanced analysis. But I like to highlight here that, let's just suppose that a student got 10 wrong on a more challenging test. Their score on that test is a 730. And that's a transformation. So somehow the SAT has a formula where they take the number correct and it maps over to 730. So in your work this week, you looked at normalized scores and linear z-scores, and then use those in a second part to predict IQ scores. So on an SAT, it's kind of the same thing. We take a raw score, and then that's sent to a formula to produce the score you see on paper, like a 730. But what's interesting is, let's say that on an easier test, a student gets 48 math questions right, only 10 wrong. On an easier test, that's a 680. So that can be troublesome for parents. It's like, wait a minute, I got 48 right last month in the 730. This month I still got 48 right, but my score went down. What gives? How is that possible that I went down when I got just as many right? But there was equating at work here. So unfortunately, the student got 48 right on a test that was easier. So the student should have gotten more correct to perform at the same level. But the College Board tries to, you know, account for variations in test questions and administrations by equating scores over. So what does this mean? If you're a teacher with students taking an SAT, or if you have children taking it, I think it's good to maybe take it twice so that you can, hopefully take advantage of the scaling. But I wanted to show you as students in this course that, a lot of thought is given to the score that shows up on paper. It's not just like a classroom assessment where it's just -1, -2, and then your score is a score. They are looking at the whole population of students who sat for it, looking at the questions and running statistics to provide a fair score that matches the difficulty of the test taken on that particular day. And then more importantly, they want to be able to have consistency across administrations over the course of the year. And that, like I said, that process is called equating. But then, we also have the transformation process that goes from raw score to section score that you see. And the same holds for the English part too. I just chose math because I'm more comfortable with it, but the same thing happens with the reading sections as well. So just wanted to show you that. I would imagine this kind of thing happens also for a GRE and other assessments where you have questions, but then a score comes up on your paper that is on a different scale. I know the GRE was in the hundreds back when I took it. I don't know what it is now. It's been a bit since I took that awful test, but I just wanted to show you the relevance of what you're learning beyond just the weekly assignment for this course.